Hello everyone, let's study about an important kind of oscillatory motion called as simple harmonic motion. It's called as SHM in short. To define this, you can say that if a body in periodic motion moves along the same path to and fro, basically means it's an oscillatory motion about the equilibrium position, and if the graph of displacement against time is a sine curve or cosine curve, then it is said to execute simple harmonic motion. That is, if you plot a graph of displacement versus time, and if that graph is either a sine curve or a cosine curve as given here. In this case, if a graph of x versus t is plotted, then it is a sine curve here. In this case, we're plotting graph of x versus t and it's a cosine curve. So for any oscillatory function or for any oscillatory motion, if a graph of displacement versus time is a sine curve or cosine curve, then such a motion is called as a simple harmonic motion. Understand this? Let's take a case where we'll consider a particle moves between two points. We'll take a case where a particle of certain mass m moves between point A and then point B, crossing point O. Here O is the reference point. Now what we'll do here is, let the particle be here at time t is equal to 0 and let it start from point O towards the positive direction. Let's call this as positive x direction. It's going towards point B. Now if you plot the graph of the particle versus time, it's somewhere here. Let it goes here, we'll draw its displacement at this point. It goes here, we'll draw its displacement here. It goes here, we'll draw displacement like this. So if we keep drawing the displacement of a particle, it's something like this. This is what it does. So we're plotting the displacement of a graph of the particle versus time. So corresponding to this, we're drawing the displacement here. We're drawing displacement here. We draw it like this. If it again comes back, it's coming back. It's somewhere like this, somewhere like this, and somewhere like this, and somewhere like this. This is the mean position of the particle. Again goes like this, goes towards the point A. Draw that also, then what you get would be, it's somewhere here, corresponding point is somewhere here, and then here, and then here, and then here. Keep plotting it and again draw backwards, it'll go to point A. This is what we get. If we join these points and see, join these points, then what we get would be a sine curve. So it's visible here that join the points, what you get is a sine curve. So the motion of the particle or the oscillatory motion of the particle in this case is a sine curve. So this would be an example of a simple harmonic motion. Similarly, you can plot the particle's motion, and the particle starts from one extreme end. So think that the particle starts from one extreme end. In that case, how will the motion be? It starts from the point B. So let the distance from point A to point B be 10 meters, which means the distance between point O to B would be 5 meters, and distance between A to O would be 5 meters. If the particle starts from this position, let us draw the graph for it. It's somewhere here, and if you take a snapshot, it's somewhere here, and then here, and then here, and then here. It goes like this, and then here, and then here. It goes like this, and then it again goes back. You get a graph like this. It will be like a curve, like a cos curve. It is something of this kind. Go like this and go like this. It will be a cos curve. So in this case, what is find is, we find that the displacement versus time graph would be either a sine curve or a cosine curve. To make more sense out of it, let's redraw it. The particle was starting from some point. Let us call this point, say, A. The center was point O. This was point B. We assume that the particle starting from point O. Distance between point A to B was 10 meter, which means from O to B would be 5 meter, and distance from O to A would be again 5 meter. Now, if we draw a graph of displacement versus time, something of this kind. A graph of displacement versus time. Starting from the reference point, so it will be 0. As time is increasing, it will start to cover more distance. Keep on covering, somewhere maybe like 1 meter, 2. It'll keep on covering, and that draw the graph, it will keep on going like this. Then it goes to point B, it will have maximum displacement. So this will be 5 meter. It will stop at point B, will again come down. So it's coming down towards point O. It will have a decreased displacement. So it is decreasing. It comes to point O, it will have a 0 displacement. Again, it is reverse direction. So it will again have a displacement of 5 meter in the reverse direction. It will go like this. It's crossing point O and going towards point A. Again 5 meter in the reverse direction. It will stop. So when the particle stops at point O, it will have maximum displacement in the negative direction, as shown by this graph here. Again, it is going towards point O, so the displacement is decreasing and it will decrease. So this corresponds to the particle being at point O. Let's call this as point 1, this is point 2, this is point 3, this is point 4. So the point O or the point 0 corresponds to point O here. Corresponding point to 0 would be O. Corresponding to point B, it will be point 1. Again, corresponding to point A, it will be point 3. So the particle goes from point O to point B. The displacement is increasing. Keep in mind that this is not the particle's actual motion, it's only oscillating in one dimension. This is the displacement graph along this. Now you'll be wondering why this way, because what you learned or what you remember may be a graph of x versus t, may be something of this kind. This is what you'll remember, but this is true only for uniform velocity, not in this case. So in this case, velocity will not be uniform, it will decrease, it will change. And also in this case, even a also will change, which means even the acceleration also will change. We'll see it later. This is what the graph will look like. Now when the particle starts from point O and goes towards point B, its speed will decrease. It will decrease at the point B. It will have least speed. It will stop here. So velocity will decrease at the point B. It will be 0. It turns back and goes towards point O. When it goes towards point O, the speed is increasing. At the point O, it will have maximum speed. It will again cross point O and go towards point A. When it goes towards point A, the velocity will decrease. The point A, it will have 0 velocity. So at the extreme points, points A and points B are called as extreme points. That's the maximum point it can travel. At the extreme point, velocity is 0. When the particle moves towards the mean position, this point O is called as mean position or is called as equilibrium position. When the particle goes towards the mean position, velocity will increase. Now, one oscillation means that the particle starts from one point, starts from point O, it goes towards point B, stops at point B, reverses, crosses point A, goes to point, stops at point A, again goes back to point O. That is called as one oscillation. Now, in terms of time period, if you call capital T as a time period, then the time taken to go from O to B would be 1/4 of it, because it will be O to B would be 1/4 of it, from B to O would be another 1/4 of it, from O to A would be 1/4 of the time period, and A to will be again 1/4 of it. Means we can divide the entire motion into 4 blocks here. In this case, if this is time on the y-axis, the time taken till this point, this will be t by 4th of it. Time taken to go till here will be again t by 4th of it. Time taken for this would be t 4th of it. This will be t 4th of it. Now this complete motion is called as one cycle. So any graph or any motion which represent a sine graph or cosine graph, that represents a simple harmonic motion. Keep in mind here that we're taking a case of displacement versus time. As you saw earlier, we can take any function. We can take a function of charge versus time, graph of charge versus time. We can take a function of, say, pressure versus time or energy versus time. In any such parameters, the graph is sinusoidal, that is sine or cosine, then that oscillation will be a simple harmonic motion.